6.4 multiplying. Now in the last video I talked about if your problem's given in fraction exponent, your answer should be in fraction exponent. Here, my question is given in radical format, so my answer should be in radical format. The key property here, you can multiply as long as you have real numbers together. These two can get multiplied together if your indexes are the same. If they're not the same, you cannot combine. So here, my indexes are not the same. So this right now would be my final answer. I can't do anything with that. Here now, because my indexes are the same, I can multiply those together. So this would be the cubic root of -8. I could plug that into my calculator to see if it's a nice number. And again, how you do your cubic root, you go to math, and then your cubic root or any type of index, it doesn't matter. And if I type in -8, my answer would be -2. So this answer is -2. I want you to pause this video and try to do C and D by yourself right now. Here, the indexes are different, so I can't do anything with it. That's my answer. Here, I can multiply them together. So -5 times -2 is +10. I cannot simplify this any further because if I plug that into my calculator, it gives me a long decimal. I don't want a long decimal. I want it just multiplied together, just like that. Now, let's say if I want it as a most precise answer, something like this, if I wanted to see if I can simplify any further. We're going to review simplifying your radical when there's a square root. Now we did this with our quadratic formula multiple times. So if I do my my factor tree here, remember there's a 2 here. So I'm looking for groups of 2. So here's a group of 2. There's no other groups of 2. So these two numbers stay inside of the root. So when I rewrite this, when I simplify this 1, 2, whenever you have a group of 2, one of those numbers come out. So that's where that 2 comes from, only one. In the square root, those other two numbers stay inside and get multiplied together. So this is 2 square root 6. Now it's that same idea when I have the cubic root. Can you guess what the difference is between them? Well, here I was looking for groups of 2 because there's a 2 here. Here I'd be looking for groups of 3 because there's a 3 here. So here's a group of 3, and then I'm left with just this 3 inside. So 1, 2, again, once you circle that grouping, 1, 2 comes out. I'm left with 1, 3 inside. Now, if you leave your answer like that, that's not full credit. You have to make sure to have your index there. My index here is 3. It's the same idea of when we did a problem like this. Because there's one group of 3 and x to the third, that's the same idea here. You can take out 1x. So let's simplify this, shall we? Now I have a number and an x here. So I'm going to do my factor tree. I'm also going to rewrite x to the 5th, so that's powers of 3. So I'm looking for powers of 3, so I'm going to rewrite this as x cubed times x squared. I still have 5 x's there because I have a total of 5 x's. I still have 5 x's. I just rewrote it so that it's easier to simplify. So now look at my number. I have a group of 3 3's, and this 2 is left underneath. So I can take out 1 3. Now if I can simplify my x's, I can take out this 1x right here. I can take out 1x because there's one group of 3 there. That has to stay underneath the root. So I can take out 1x, and then I rewrite what's left over. My index here is 3, so this 2 is left over, and I still have 2 x's left inside. I still have 2 x's left inside, so this right here is my final answer. I want you to try to pause the video and try to do B by yourself. So here's my factor tree. Lots of 2's here. I'm looking for groups of 3. So I'm going to circle this group of 3. Here's another group of 3. So I can take out a 2 here, and I can take out a 2 here. Notice that I put a multiplication sign because you're multiplying. Here, I rewrote this. I still have 7 x's. There are 2 groups of 3 and 6. So I can take out 2 x's. An x squared can take out an x squared. Now what I have left over, I still have this 2 underneath the root. And I still have this x underneath the root. So my final answer, then I can combine those two, would be 4x squared cubic root of 2x. What happens if I'm actually multiplying? Well, there's only one step here. Because I'm multiplying, I'm going to multiply across. I'm going to rewrite this 72 times 10. So because the indexes are the same, I can multiply. This becomes 720. When I have multiplying with the same base, I can add my exponents. This becomes x to the fourth. Here, this becomes y to the fifth, because again, I'm adding my exponents. Now this is the same problem as above. So I'm going to do my factor tree. So I have 72 and 10. I'm going to break it up with that. So now again, I'm looking for groups of 2. So here's a group of 2. Here's a group of 2. Here's a group of 2. This doesn't have any groups. I also rewrote this. So I still have 4 x's and I still have a total of 5 y's. Now I can take out this 3 times this 2 times this 2. So 3 times 2 is 6. 6 times 2 is 12. So I have a 12 on the outside. There's 2 groups of 2 in x to the fourth, and there's 2 groups of 2 in y to the fourth. So we can take out a y, x squared, y squared. Now underneath the root, I'm left with this 5 and this y. So this right here is my final answer. I want you to pause the video and try to do B by yourself. So here's your factor tree. There's a group of 3's and a group of 5's. And when I look at these x's, there's a 2 here. So there's 3 groups of 2 for the x's, 3 groups of 2 for the y's, and there's a y left over. So what I actually have my final answer, this would be 3 times 5, because that both comes out, so that's a 15. I can take out x cubed. I can take out a y cubed, and what I have left underneath, this 7 had no pairs, and this y did not have a group. So this right here is my final answer. What do you do when you have radicals and exponents? Again, it depends on what is given to you first. When you have what's given to you first, you should always try to simplify the radical with the exponent. But here, unless if you have fraction exponents, that is a little different. But here you always want to try to simplify it down. And that's all you got here. Have a great, grand, what?